So here a few more points we can discuss here. Electrons are revolving around the nucleus in circular paths. They are called orbits. The nucleus is present at the center of atom. Now we are saying that nucleus is present at the center of the atom, where the mass is also concentrated. So that's why we will say this is called nuclear model. Then electrons and nucleus, electrons which are revolves around the nucleus, they are strongly held together by electrostatic force of attractions. They are strongly held together by electrostatic force of attractions, and electrons revolves around the nucleus in circular paths. How the planets revolves around the sun. That's why this alpha scattering experiment is also called as planetary atomic model. So what we are saying that electrons revolves around the nucleus in circular paths. They are called orbits. The mass is present at the center of the atom, where the positive charge is present. So the positive charge we are considered as nuclear model and nuclear model of an atom, and electrons and nucleus are strongly held together by electrostatic force of attraction. So this is also called planetary atomic model. How the planets revolves around the sun, like electrons revolves around the nucleus. So that's why it is also called planetary atomic model. Okay, now we will see the order diameter of the nucleus and atom. So X-ray studies gives information about the diameter of the nucleus in the order of 10 to the power of minus 12 centimeter to 10 to the power of minus 30 centimeters. The atom has given 10 to the power of minus 8 centimeters. If you see the ratio of the radius of the atom, radius of the nucleus. If you observe the ratio of the radius of the atom to the radius of the nucleus, that is 10 to the power of minus 8 by 10 to the power of minus 30. So size of the atom is 10 to the power of 4 or 10 to the power of 5 times greater than the nucleus. And if you see the value, so value is equal to that is a AQ. Is it clear? So value of the atom is by value of the nucleus, that is equal to 10 to the power of minus 8 cube, 10 to the power of minus 30 cube. So that is 10 to the power of 50. So the value of the atom is 10 to the power of 15 times. How much? 10 to the power of 15 times more than the value of the nucleus. Is it clear? Suppose if you take 10 to the power of minus 12, then you will get 10 to the power of 12. So the value of the atom is 10 to the power of 15 or 10 to the power of 12 times more than value of the nucleus. Is it clear? So X-ray studies gives information about the diameter of the nucleus in the order of. So nucleus has a diameter 10 to the power of minus 12 or 2 10 to the power of minus 30. So the ratio atom has a diameter 10 to the power of minus 8. So the ratio, if you observe that the value, the radius of the size of the atom is 10 to the power of 4 or 10 to the power of 5 times greater than the nucleus. So you see the value. So value is 10 to the power of value of atom is 10 to the power of 15 times or 10 to the power of 12 times more than the nucleus. So just you can imagine that if you take the cricket ground, if you take the cricket ground total, if you keep the ball in the middle of the cricket ground, so how that cricket ball is present in the entire cricket ground, like the nucleus is present in the atom. Suppose if you take the cricket ball in the ground, so how that it looks like this, like the same the nucleus is also present in the atom. Okay, what are the main drawbacks or limitations of Rutherford's alpha ray scattering experiment? So, according to that electromagnetic theory of Maxwell, if any charged particle moves under the influence of attractive force, it loses the energy in the form of electromagnetic radiation. So, what we are trying to say that if any body which is charged, which is moving under the influence of attractive force, it has to lose the energy in the form of electromagnetic radiation. So for your understanding purpose, I would like to say one thing. Suppose one person, I am here, I am taking the classes continuously, isn't it? So how much time I can take the classes? So maybe 1 hour, 2 hours, 3 hours. So slowly what is happening there? I am losing my energy continuously. So finally what will happen? At the end, I have to stop the class. Why? Because the energy of mind is continuously reducing. Like that, while the electron revolves around the nucleus in a circular path under the influence of the nucleus, it has to lose the energy. I hope you can understand. When electron revolves around the nucleus under the influence of the nucleus, attractive forces, it has to lose the energy in the form of electromagnetic radiation. So look at it like this. Finally what will happen? It has to fall into the nucleus. Atom has to collapse. But what is happening then? Atom is stable. So electrons revolve continuously and finally it has to fall into the nucleus by emitting the electromagnetic radiation. So atom has to collapse, but atom is stable. Yes or no? Atom is stable. So why it is not happening? This thing was not explained by the Rutherford. First thing, when object under that is moving in nature under attractive interactions, it has to lose the energy. It has to lose the energy in the form of electromagnetic radiation. But it is not observed in the Rutherford's alpha ray scattering experiment. And one more. When electron revolving around the nucleus, it has to lose the energy. So in the form of electromagnetic radiation. If you observe the spectrum, while it is using the energy in the form of electromagnetic radiation, the spectrum must be continuous. The spectrum must be continuous. Continuous spectrum. We have to observe the continuous spectrum. So continuously there is moving under the influence of the nucleus, attractive forces of the nucleus. So it has to lose the energy continuously and the spectrum must be continuous. But experimentally it said that are having that fixed lines with frequency, definite frequencies. Instead of continuous line, they are having one break lines, you can see. Is it clear? Instead of continuous line, they are having break lines with particular frequency. Is it clear? So, what is the reason for that? So, it does not explain the discrete energy levels. You speak the word here, discrete means not continuous. What is that? Discrete means not continuous. So discrete energy levels were observed instead of continuous spectrum. So this is not explained by the Rutherford's alpha ray scattering experiment. And one more thing, it does not give information about the energy of the electrons. Energy of electrons. It does not explain the energy of the electrons. So, is it clear? So, it does not explain the energy of the electrons. These are the main drawbacks of Rutherford alpha ray scattering experiment. So what are the drawbacks first? According to the electromagnetic theory of that Maxwell, so any charged particle under the influence of the attractive forces, it has to lose the energy continuously. Finally, it has to fall into the nucleus. But here atom is stable, so that is not explained by the Rutherford. And when electron loses the energy continuously in the electromagnetic radiation, that spectrum must be continuous. But the spectrum is discontinuous with fixed lines with fixed frequency. Definite lines with fixed frequency. Is it clear? And it does not give the information about the energy of the electrons. Energy of the electrons.